All right, guys, I want to go over this third FRQ with you for unit number 3. We're going to kind of jump right into this one. There's a little bit of math involved with this, but again, we'll go through each answer individually. So this one deals with zebra mussels, and it mentions here that the zebra mussels are native to the Black and Caspian Seas. They were first detected in the Hudson River in New York in 1991. And I think this is a real critical sentence here. It says, before the arrival of zebra mussels, the Hudson River supported populations of native unionid mussels. So that was a different species of mussel that occupied the river prior to the invasive species getting there. So you can probably imagine what happened to the unionid mussels in the river, after the zebra mussels got there. So, question A says, describe one way an invasive species such as the zebra mussel can decrease the carrying capacity for a native species in an ecosystem. So again, kind of the thing here is they want just one thing. They don't want more than one. So if you listed 3 or 4 things, they're only going to grade the first one. All right, so let's take a look at some possible answers that you might have put. Um, I think this is probably one of the more common answers that I'm going to see. Invasive species can prey on the food sources of native species. So that would really affect the unionid mussel, obviously. This probably would also, this is kind of, I guess, along the same lines. This one says that they can outcompete the native species for resources. It's a little bit more general. If you're going to use this word, okay, um, I'm going to highly suggest that you back it up with a specific resource. So you might say food, or water, or habitat or living space or something. Those would all be pretty good answers. Which kind of leads us to the third one that you may have put down. Invasive species can outcompete a native species for habitat. All right, so for living space. And again, I think those would be perfect answers. Any of those would really work. The fourth one here that they talk about is invasive species acting as pathogens, or the ability to spread pathogens. I mean, sometimes invasive species can cause diseases, in not only the native species, but maybe even the food that the native species eats. I wouldn't have expected many people to put this down for an answer, but maybe it's something to think about down the road for a possible answer that you could put. But I would think, habitat, reducing the food of the native species, those would all be pretty good things. All right, question B. Identify one characteristic, again, one, of an R selected species that would increase the likelihood of the R selected species being a more successful invasive species than a K species. All right, so we have to think about, all right, like zebra mussels, like they're pretty, I guess they're pretty effective at being an invasive. So think about the characteristics of an R species and think about how that relates to a zebra mussel. For example, zebra mussels reproduce super fast, right? So that kind of makes them an R selected species, right? So having that ability makes them very successful at being an invasive. Shorter gestation periods. They thrive in disturbed or changing habitats. They mature quickly. They produce a lot of offspring. I mean, these are all things that are basically your R selected characteristics, but that's what makes invasive species so successful is that they have those characteristics. So you just had to list one thing. And if you did, then you're good to go. All right. So these first 2 questions, when I'm grading this, I'm looking real closely at those two. And if we didn't have one of those answers, then I'm going to take a couple points off. So make sure that we hopefully have that. All right. Now for letter C. Letter C gets into some of the math. So it says the table below shows changes in the population densities of zebra and unionid mussels from 1991 to 2015 in 6-year intervals. So you notice 91, 97, et cetera, et cetera. Here we have the zebra mussel density. And I guess one thing to kind of look at here is just kind of look at the overall, I guess, kind of trend. It went from 0 and then it just exploded in like a 6-year span. And then it sort of went down a little bit and just kind of leveled off a little, kind of fluctuated a little bit, maybe up and down. But you'll notice, I mean, between 91 and 97, there was probably some massive exponential growth. Now, in that same time frame, look to see what happened to the union in mussels. So when those zebra mussels were overpopulating, then you can see the impact that it had on the union in mussels, right? So let's go ahead and jump into this first kind of sub part of question C. It says, based on the data, calculate the percent change in the population density of union in mussels from 91 to 97. So 91 to 97, we want to see how the person, or see what the percent change was in the unionid mussels during that time. Now, I will say that when I originally gave this problem out, I did have a typo in the formula. I did correct that, and I did send out a message to you guys about that. If you submitted this before you got that message, then you may have worked this problem out incorrectly because I gave you the wrong formula. Don't worry about that. I'll know what you did. But this is the correct formula. To find percent change, it's the final population minus the initial, or the population density in this case, divided by the initial, and then times that by 100. So if you have your calculators, so if we're looking at these numbers here, right, from 1997, or I should say 1991 to 1997, 1997, 2 here in this case, that's the final. All right, so we would take 2 minus the initial, which would be 8, and then divide that by the initial, and then times it by 100. So here's what the work looks like for that, okay, right here. All right, so I would expect when you're doing the work for this problem to be able to show me this, right? 2 minus 8 divided by 8, and then times that by 100, and you get negative 0.75. And then just, and it, well, 2 minus 8 divided by 8 is negative 0.75. And then when we times that by 100, that's when we get negative 75%. The negative just tells us that the population went down. Okay. It's kind of an absolute value type of a thing. So if this was your answer, this is fine. Okay. But just understand that the population changed by 75%. It just went down by 75%. Whether it went up by 75 or down by 75, it changed by 75. All right, so if you put either negative 75 or 75, I'll accept either answer. Okay. Now for the second part, which is similar, it just says calculate the percent change in the population density of the zebra mussel from 2009 to 2015. So here we're looking at 2009, 2015. We want percent change. Now notice how the density went up. So we would expect the percent change to be positive, right? So again, we're going to take that same exact equation, final minus initial divided by initial times 100. So in this particular case, we're going to take 2750, which is our final, minus 2000, which was our initial, divided by 2000, and then times it by 100. All right, then we get 0.37. We multiply that by 100. We get 37%. All right, so that would be the answer to the second part. Couple more questions here. Letter D says scientists want to reduce the population of zebra mussels in the Hudson River. Propose a solution for reducing the zebra mussel population in the Hudson River. So just coming up with a solution is one thing. And then the second part says describe a potential negative consequence, ecological consequence, of your proposed solution for reducing the zebra mussel population in the Hudson River. So we're going to kind of look at these two questions kind of together. Okay, so the first thing that you had to do was come up with a solution. I like this answer. Introduce a predator to eat the zebra mussels. Okay, that's good. Now, If that's what you wrote down in the second part of the question, you had to come up with a negative consequence. So if you said introduce a predator, one negative consequence might be, well, that predator can eat a bunch of other things too, right? So that would be a way to come up with a negative consequence. Some of you may have put chemicals in the water, maybe some kind of a, I don't know, some kind of a chemical to kill the mollusk or kill the mussel. If that's what you put down, then those chemicals can also kill other organisms too, right? They can even get people sick, right? If you ingest that, so it can pollute the water possibly. Introduce a pathogen to kill the mussels, so that'd be like a disease. If you did that, again, pathogens can kill other organisms too. A lot of you put something like this: physically remove the zebra mussel. Okay, now that could be a lot of things, right? I mean, scooping them up with a net, um, you know, scraping them off of boats or something. I mean, whatever, something to physically take them away, and then some consequences that might occur from that. Physical removal could end up damaging the habitat. That could possibly be something. It could also damage other organisms. That could happen as well. I would think that the second part of this question would probably be the hardest part. All right. So, like, if you come across something like this on the AP exam, if they ask you to come up with a solution and then come up with like a negative consequence, try to at least come up with a solution, because you'll get a point for that, and then the other point comes from the other part. If you can't get that, that's okay. All right, but do the best you can with that. Okay, so these are some good examples. All right, guys, have a good day. I will see you soon.